Hey everybody, I'm Chili. Welcome back to Beginner C++. And without further ado, here is Snake Game Part B, the snakening. And that is all of our functions for the snake, for the very basic part of our snake. Let's see if it builds. So it does indeed build. Now we want to test it out. So we got to go. Oh well, what is happening here? Thank you very much for not refreshing your screen. But anyways, so we want to go into game.h, I suppose, and let's add a snake to the deal here. First, we've got to include snake.h, and then we want to add a snake. And we go down here. I'm going to get rid of this test code. We've got to initialize our snake. So we go in here and we go snake. And we've got to pass in a location to initialize this guy with. So we can create a new location with these curly brackets. And let's just go 2, 2. Seems relatively good to me. And what else? Well, we've got to handle some keyboard input bullshit. So we set up some keyboard code like this. You know, you've nothing new here. But we need to change some things. We need to add some things. First of all, I made a mistake here. I made a big mistake because this is not snake, right? This is obviously going to be snake. So we got to change the name of snake to snack. Otherwise, it's not the snack game. And next thing, so these key presses, what are they going to control? Well, we're going to have them set a delta location. So location delta loc, and let's set this initially to 1 and 0. And we'll go into here. And now, if you pressing key up, then delta location is going to be equal to 0 and -1. And do the same for the other key presses, like so. And then we're going to update our snake based on the delta. There we go. And in compose frame, we are going to draw our snake. Draw. And pass it our board. And all should be good. So let's build this, see how it works. First of all, let's increase the size. Why are you not redrawing this? This is pissing me off. Where's my board? Here it is. I've got... Can you please, stop now? Because this is actually the worst. Okay, so let's increase the size of the board to, I don't know, what can we have? 30? I think 30 will still fit within the window. Let's try 25. I don't want to push it. I don't want to push it some more. So, build that. Start with debugging. And as you can see here, the snake moves incredibly fast, which should be sort of expected when you consider that it is updating once per frame. So on my computer, I'm running 60 frames a second. That snake is going to be moving 60 squares per second. A little too fast, if you ask me. Now, what we're going to do here is we're going to create an int, and we're going to call it, let's see, we're going to create a static const expression int snake move rate, or snake move period. So how many frames does it take the snake to move, to make one move? And we're going to set this to, 20 frames. That's 3 movements per second. That's fairly quick, but not too quick. And then we're going to go int snake move counter, and we'll set that equal to 0. And in here, we are going to go, first off, snake move counter, increment the snake move counter. Then if snake move counter is greater than or equal to snake move period, reset the snake move counter. Snake move counter equal to 0 and move the goddamn snake. How do you like them apples? Now the snake is a little more responsive. By responsive, I mean it doesn't just, fuck off the side of the screen super fast. And there you go. Assertion fail. Why are my graphics just totally fucking shit in the bed here? No, I don't want to ignore. I want to fucking abort. There we go. It's kind of hard when you can't read the dialogues. Anyways, we're going to soldier through this shitstorm of bad bullshit. And we need to test the snake's ability to grow. So what we're going to do is inside of here, every time the snake moves, it's also going to have a chance to grow if control, I imagine that is what it's going to be, then snake dot grow. And let's just put that there. So reset the move counter, grow the snake if control is pressed, and then move the snake. And we're going to start with debugging. Snake is moving. Let's press control. Snake is not growing. This makes me sad. Let's see if I press the other control. No, I think the snake disappeared there once. Oh, wait. So, yes, if you move... I think I know what's happening here, maybe. I think the snake, actually, the segments of the snake might be black. And so they're getting drawn over top of the head of the snake, and that's causing some problems. So, why are the segments be black? That's what I want to know. Snake. Your head, your body color is green. Init body. Okay, so this is super dumb because I did the dumb thing. And when I called the grow function, where's the grow? I was like, you only need to increment the segments. But that's not actually true. So n segments points at the next free segment, the next unused segment in the array. So what we want to do is first we want to go segments. And then we want to go at n segments. And so in the next unused segment, we want to initialize it as a body segment. And then we want to increment the n segments to indicate that the number of used segments has increased. So if we do this, then we press the control button. Now our snake is motherfucking growing. And if I release control, now you can see it's doing its snaky snake thing. And I'm happy with this. I am super happy. Because things are working as expected. Now, this highlights why it's always good to test your shit before you go on and add more shit to your program, because you probably fucked something up, and it's nice to get that out of the way when you're sure what it is you've just created. You know that the thing you fucked up is probably the code that you just wrote. So the less code you write before testing, the less things you have to check to see where you fucked up. Pretty smart, huh? Alright, now that we have got the snake moving, we've got to set up the fail condition for the snake. So there's two main fail conditions. One is the snake collides with itself, and the other is the snake collides with the wall. So let's start with the snake colliding with the wall. So we're going to go into board.h, and we're going to add a function in here. Bool is inside board, we'll say. And we're going to do a constant location, and this is going to be a constant function because it's not going to change anything about the class. And it's pretty straightforward here. All you're going to do is return location.x greater than or equal to 0, and x is less than width. And we do the same deal for the y coordinate. Now, once we have that, we're going to use it to test the snake. So what we want to do is we want a function that is going to give us the position of the head of the snake after a delta is applied, and we'll use that information to determine whether that next move will put the snake into a death situation. So let's create another one here. We're going to go location, get next head location, and we're going to input a delta into this. And this is constant because it doesn't actually change the snake. It only gives us information on where the snake is going to end up next after a delta is applied to it. And we'll create a definition in here. Where is it? There we go. And what are we going to do? We're going to return a location. So let us create a location. Just call it L. And that is going to be a copy of the location of the head of the snake. So segments at 0 dot, no wait, just segments at 0. That's crappy. We can't get the location of a certain segment. All right, so we need to be able to get the location of a segment in order to add this delta to it and then return it. So we're gonna expose that. You know, I could do some dumb bullshit and twist myself into knots, avoiding having to expose shit, but why not just fucking, it doesn't matter. Let's free the location of the segment. So get location const, and we're going to create that definition of that, and we're just going to return location. Then we don't need that anymore. What we're going to do is we're going to go segments at 0, which is the head, dot get location. And this is going to return a copy of the location of that segment. It's going to return a new shut up. Going to return a new location object, and then we're going to call on that object add, and we're going to add the delta location. And oh poop. Right. That's not going to work because add doesn't return a location. It returns void, so we won't be able to return from there. All right, well, I had, best laid plans of mice and men and all that. Location, L. So we're going to initialize the location as a copy of the location of the head. And then we're going to go L.add delta location, and then we're going to return L. There we go. And this will get the next head location after this delta is applied. And we can use this information in game.cpp to determine whether that is going to go off the board. Now, let's add a variable here. We're going to go bool. Game is over equal to false. There we go. So what we're going to do here is, first, if it's time for the snake to move, we're going to test to see if that movement is going to bring it into death. So if snake dot get next head location delta location, and here we're going to go, let me think here, board dot is inside board. And here we're going to put a not in there. So if the next head location is not inside the board, set game is over equal to true. Else do all this dumb bullshit here, updating the snake. And this stuff here is only necessary if not game is over. So let's put that in those terms. And next in here, compose frame snake.draw, and if fuck you game is over. Okay, so remember when I said that this is basically just a fresh project with the addition of the rectangle code? I was actually lying back then, because here you see I've added a couple of files here. I've added something called the sprite codex header and CPP, and it contains a class called the sprite codex, and this class only contains static functions, and these functions are functions to draw sprites. So they have all the Mondo put pixel calls in there, and the reason why I did this is to keep these tons of put pixel calls out of our game.cpp and so forth, so that fucking doesn't lag out our text editor. So what we're going to do is we're going to go up here, and we're going to go include sprite codex, and then down here we are going to go sprite codex and draw game over. And I don't know what a good place to put it at is, but I'll just put it at 200, 200, and pass it graphics, because it needs that. And there you go. So this is nice. It keeps this dirty put pixel code out of the rest of our project. It keeps the build times down, except for the first one. The first one is going to take a long time to build, trust me, because the title screen is way bigger than the old title screen. But anyways, so we draw the game over screen if the game is over. We keep drawing the snake because, hey, why not? But we only update if game is not over. Yes, so this should maybe work, if it even compiles. Sprite codex is going to take a while to compile, because I believe there is about 30,000 or 60,000 lines of code there. And let's run this fucker. Alright, so now we got our snake. If I hold control, I can make the snake grow. Let's bring the snake off the side of the screen. And there you go. Game over. Beautiful. Now we want to make it so that the snake dies if it collides with itself. So back in snake, we're going to add a function bool is in tile to see if the snake occupies a certain tile. And we're going to go const location. That's not an ampersand. And no, I don't want to give it location again. I don't know. Target, whatever. Fucking doesn't matter. And this is constant because we're not changing anything. We're just doing a query. So now we gotta go. Where's my refactoring? So we've got to check every segment of the snake to see if it matches this guy. So for every active segment of the snake, what we're going to do is we're going to check to see if that segment's location is equal to the target location. So if segments at I dot get location. And actually, now that I look at it, get location here, it's returning a copy of the location. But sometimes we don't want to copy that. We just want to reference it. So we're going to change get location for the segment here. Let's go into here. Where's get location? And we're going to make it return a const reference to the location, because we don't always want to make a copy. Sometimes we just want to look at it. So where is get location? Where is that? Should be, yeah, it should be complaining here because we changed the signature. All right, so now it's going to return a constant reference to the location of the segment, which is what I like. All right, so back to business here. Segments at I dot get location is equal to target. And if they are equal, then we want to return true because the snake is in the target tile. Otherwise, if it runs through all of the segments and hasn't found any that are equal, return false. All right, now here's the problem. No operator matches these operands. So we have defined our own type called location, right? But location right now, it doesn't have any kind of operation defined to compare two locations to each other. But in C++, we can define operations. We can define the meanings of operators for objects. And it's very common to define equal or equivalence operators for your object. So let's go into location, and we are going to overload the operator. We're going to define the operator. So what we're going to do is and this operation returns bool, right? It's comparison, returns bool. Operator. You see, it turns a different color because that's a special word in C++ language. It's a keyword. And the operator we wanted to define is the equivalence. And it's going to take a constant location reference, and we'll just call this one right-hand side because this is the right-hand side of the operand. And it's constant, doesn't change the state of the object, and we're going to return x is equal to right-hand side dot x, and y is equal to right-hand side dot y. And there you go. We've just defined the equivalence operator for our own type. And I'm going to say now that this type here is no longer just dumb data. It is starting to have behaviors, and let's change it to class. It doesn't matter either way, but making it class will make things, I don't know, better in my brain. But I'm still going to make everything public, because even though it's a class, it's also a very basic kind of data type. But it doesn't matter if you make a class or struct, it's all the same. All right, so let's go back here. And now this complaining has stopped. The compiler has stopped its whinging. It is now happy with us comparing these locations to each other. So what is next on the menu? Well, now that we have this function is in tile, let's go to game.cpp. And let's check here. So if not inside board, or if actually, if we're going to get the next head location, let's not call that function twice. Let's go location next is equal to get next location, and then here we'll use that, and then here so if not inside board, or if snake dot is inside tile next, then it's game over. So if the next tile we're moving to well, I can already see a problem with this, but we'll cross that bridge when we come to it. I'm going to make this constant because it's not going to change, so it's nice to make it constant here. But yeah, so this should trigger the game over when the snake collides with itself. Now let's grow the snake a bit. Get a nice long snake, and now we're going to go like this, and bam, game over. So the snake dies when it tries to hit itself. Now the problem with this code that I was alluding to before, let's see if I can demonstrate it here. So I'm going to grow the snake. Feeling super hard at this. All right. There we go. So you see here, I've reached game over. I tried to move up on the snake here, and it detected that as a fail condition. But if the snake moves up, this end of the tail is going to move forward. So in actuality, this should not be a fail. But what we're doing is we're testing the next position of the head against the old position of the snake. But when the head moves to that position, the end of the tail is also going to move. So this test isn't really valid in this situation. So what we should do is, basically, we want to do the test, but we don't want to test the final tail part. The reason for this is, when the snake moves, the the final tail is going to go to the new position, so it's going to become vacant. The tile that the end of the tail occupied will become vacant after the snake moves. So we want to test, but we want to exclude the very end of the snake. So what we're going to do is we're going to go into snake.h. We are in snake.h, maybe. We want to change is in tile to what? So I'm naming it is in tile except end, and it's a little awkward. I'm not gonna lie. It's maybe not the most elegant solution, but it'll get the job done. So is in tile except end, and here we are going to loop from I equals 0 to I less than n segments minus 1, and this is going to check all of the segments except for the very end. And that'll be great for our self-collision test. Now we go into game.cpp, we go is in tile except end. And if I test this, it should work. So you see here, I can make the snake follow its own tail like this, and it won't cause a game over condition. All right, it's time to tackle the final part of this puzzle here, which is the actual goal that the snake is trying to reach. So what we're going to do is we're going to create, another header file, call it goal. We're going to include snake and board. We're going to create the class goal. Now the goal is obviously going to have a position, so we're going to call that location loc, and we're also going to give it a color, which is just going to be a constant. And for our purposes, I'm just going to set that to red. And what I'm going to do for the goal is I'm going to give it a constructor, goal, and we'll leave that for us right now. And I'm going to give it two functions. One function is going to be void respawn, and that is going to take, what is it going to take? It is going to take std MT, we're going to need random, aren't we? So # include random if we want to specify this thing. So it's going to take the random number generator, MT19937 is going to be a reference to the random number generator. It's also going to take a constant board ampersand BRD, reference to the board, and a constant snake ampersand snake. Let's take a reference to snake and a reference to the board. Why are you complaining? You'll get over it. Okay, good. You worked it out for yourself. Void draw, and this one's also going to be drawing to the board BRD. And it's going to be constant because it's not going to change the state of the goal. So we respawn, we draw, and let's say constant location reference get location const. So we can also get the location of the goal, which will be useful to test if the snake is going to eat it. So now we want to, okay, so the constructor is going to take the same kinds of information that respawn has, because it's just going to call respawn to set up the initial position of the snake. So let's do that. So we're going to define this, and all we're going to do is call respawn. And we're going to go RNG, BRD, snake, and it's all good. Now the next thing is the respawn. So this is where the magic happens. Create definition of respawn. So what we're going to do here is we are going to create two distributions to randomly generate the position of the goal. So we've got two distributions here, the X and the Y, and they are going from 0 to the far right and 0 to the far bottom of the grid. Now what we want to do is we want to randomly generate the position of the goal, but the problem is that the goal, we don't want to generate it in a place where the snake already exists. So what we're going to do is we're going to have a do while loop. And we're going to, well, first of all, we're going to set location, new location. And what we're going to do is we are going to generate new location equal to X distribution RNG. And wait, that's not good. New location dot X. That doesn't make any sense if it's just, you can't assign an integer to a location. So new location dot Y is equal to Y distribution RNG. And we're going to do this while snake dot is in. Here's the problem. So we don't want to use is in tile except end, because in this case we do want to check to see if the end is in there. So we got to go back to snake and we've got to copy this, paste it, and we just do a straight is in tile function. And then we're going to go into here and we're going to copy this. Again, it's not the most elegant of solutions perhaps, but you know what? It's going to get the job done. And there we go. So now we're just testing all segments. So there is in tile and is in tile except end. And they both have their applications in our system here. So while snake dot is in tile new location. So while the snake occupies the tile of the new location that's been generated, regenerate. So we just keep regenerating randomly until we generate one where the snake doesn't exist at that tile. And then we do location is equal to new location. And that's it for the respawn function. The draw function is, I'm pretty sure you don't need me to tell you how to do this. Board.draw cell location color. And what's the last one here? Get location again. Constant location, and so return location. There you go. And that is it for our goal class, if I'm not mistaken. So now we go into game.cp, game.h though. And we include, where is it? There it is, goal.h. And we add a goal. We've got to make sure that we add the goal after the board and the snake, because board and snake are going to be used to initialize goal in here. So goal, and we look at the constructors, we got the RNG, and we've got the board, BRD, and we've got the snake, SNIC, and that should be fine. Good. Now let's make sure, no, bad. We've got to have the RNG initialized before the goal, because it's being used to initialize goal. So we want that to be initialized before goal, like this. Goal first, RNG first, then goal. Now we're going to use this information here to control the growth and whatnot. So if we're not dying, then we're going to check to see if we are eating. So if next is equal to goal.getLocation, then we want to grow the SNIC, and we want to goal dot, no, this is bad, because what we want to do is we want to grow the snake and move the snake and then regenerate the goal, or respawn the goal after we've moved. Because if we respawn before we move, we might respawn it back where it was before, and that wouldn't make any sense. So what we want to do is, if bool eating is equal to this. So first we check to see if we are eating, and we remember that in a constant bool variable. Then if we are eating, grow the snake. Then move the snake. Then if we are eating, after we've moved, goal dot respawn RNG BRD snack. And this should, if I'm not mistaken, be good. So we draw the snake, we draw the goal to the board, and so now we only grow when we eat. So if I eat that, I have grown. And if I go down here, boing, and if I eat this, grow again. Grow again. And now this is starting to be good. This is starting to make some sense here. Oh, a little tricky. There we go. Beautiful. So this is working. And let's just, let's try to commit suicide just to make sure everything's working here. I'll go off the side. Yeah, game over if I hit the edge of the screen there. Alright, so now we've got the basics of the snake game down, but as you can tell, it's lacking polish in a bunch of areas. So for the homework, what I'm going to get you guys to do is to polish it up a little bit, finish this mother off, and maybe extend it or make it a little more interesting. So here are some ideas of things that I think probably should be added. First off, there should be a border drawn for the board. Because you can't see where the wall is, you don't know, like if we go too far to the right, we don't know when we're going to die, and that's kind of a problem. So you're going to want to be able to draw a border, and you're going to want to be able to adjust the position of the board as it's drawn on the screen. Right now it's just drawn at the top left, but you'd want to be able to position it so that you could draw it maybe in the center of the window or whatever. The other thing is, of course, you're going to want to, I've already put the code in for the title screen. You've just got to implement it so that it draws the title screen until you press enter or whatever, and then it starts the game. What else do you want? You can make it so that there's padding between the tiles. As you can see right now, the tiles are just all connected to each other. I'll show you later an example of some of this stuff, but I like it better with a little bit of padding between the tiles, but your mileage may vary. You can make it so that the snake actually has a pattern in its segments, and that looks really cool. And it also makes it easier to see the movement of the snake. And you can make it so that the snake speeds up over time or based on some kind of condition, because right now just going at the same speed is kind of boring. And for extensions of the game, there's like an infinite amount of possibilities of what you could do to make this game more interesting. But for one simple example, you can make it so that obstacles randomly spawn in the field as the game progresses, making it more difficult to maneuver around with the snake. But that's just one example. Let me show you an example of how some of those things can be implemented. So here's a test of the snake game that I did when I was just, planning out this lesson. And as you can see, it's got a bunch of those things I talked about. It's got the border around the table. It's got the randomly spawning obstacles, obviously, and it's got what else has it got? It's got the padding between the cells, which I think looks spiffy, but I don't know. Maybe you like them better connected. It doesn't really matter. One thing that I do recommend though is the pattern on the snake's segments, because that makes it. You can see right now that it's making the snake. It makes it easier to visualize the movement of the snake. All right, and as you might be able to tell, the snake is actually speeding up as the game progresses here. So it's getting more and more difficult to control it with precision, but I'm managing so far. There we go. Let's get this one. And so these are some ideas of things that you can add to the game. And that list that I gave you, the list of things is going to be on the wiki. And that's the list of things that I'm going to cover in the homework solution. But don't limit yourself just to those things. Figure shit out for yourself. What do you think would make this game more interesting? What kinds of shit would make this fun? And go with it, man. The sky's the limit. You got the power. All that jazz. I'm gonna die. So that's that end of the game. But yeah, that's Snake Game in C++ with, full-on object-oriented programming. One thing I'd like to say about all this encapsulation, const correctness, and object-orientedness stuff is it's better that you code in a suboptimal manner than not at all. So if you're having trouble thinking and coding in terms of objects and classes, or you're having trouble implementing encapsulation and data hiding, if you find this stuff hindering you and discouraging you, then fuck it. Forget about creating classes or hiding data. Just write functions and loops with loose data if that's what you need to get by. I want you to think about these ideas. I want you to be exposed to them, and that's why I'm showing them to you now. I'm showing you the model, but it's okay if you're not quite there yet. But you gotta code. You got to keep coding, and one day you're going to get there. Just don't close your mind to this OOP stuff. Keep it in the back of your mind, think about it, and at the same time, just code, move forward, even if you can't do exactly the way I'm showing you. Anyways, as for the Snake Game, good luck polishing it off and making it all spiffy. I'll be back soon with a video that shows how you can implement all those bells and whistles. Until then, I hope you enjoyed the video. If you're interested in helping support my work, I've got a Patreon that you can check out. I post some exclusive content there, and they got a bunch of perks for patrons. You can also support my work by spreading the word on social media or, any kind of community you might be a part of. And I encourage all of you to join us in the Planet Chili community, in the Discord or in the forum, or both, and, learn, share, and just, generally meme with us. And I will see you soon with some more C++.